Okay, everyone. Hello. We're going to look at a few of the homework questions together, just the ones from the textbook. And then we're going to move on to giving you a couple of challenge questions that I'd like to discuss with you before I actually assign them. These will not be to hand in. They're just for challenge. See what you can do with them for your learning. Okay, so let's start with the one that you see on the screen right now. The highest dam in Canada is the Mica Dam, one of 3 dams on the Columbia River in British Columbia. From a point 600 meters from the foot of the dam, the angle of elevation of the top of the dam is 22 degrees. What is the height of the dam to the nearest meter? So this is what I was talking about during the lesson yesterday, is what happens if they don't give you the picture. Can you draw the picture yourselves? Now this is actually a quite easy picture to draw. So I'm just going to do like a side view of this whole thing here. So let's say that this is the dam, and you are standing 600 meters, which is supposed to be a straight line there. Sorry about that. There, that's pretty good. 600 meters away from the foot of the dam, and we're going to assume that that's a right angle. And then they say that the angle of elevation to the top of the dam is 22 degrees. So if you're standing here looking up at the top of the dam, you're going to have a line going like this, which is your line of sight, and the angle of elevation is then what you have to put in there. So you've got to be very careful. I have had students put the angle of elevation in the top corner here. The angle of elevation is, like I said, what would your nose sweep through, tilting your head upwards towards the top of the dam, and that's where the 22 degrees goes. Now they didn't tell us our height in this question. And this is what I was talking about yesterday too. There was that one question where they had given the height of the theodolite. If there's a person standing here, you technically would have to add the person's height to the height of the dam, because the dam would actually extend below. But they didn't say that here. So we're assuming that the measurements are taken from the ground, so we don't have to add the height of the person. But sometimes you do, so just be careful with that, okay? So with these two measurements of the angle and the side length, we can now label our triangle with opposite, adjacent, and hypotenuse. So it is a right angle triangle, so this side, which is the side we're looking for, which I'm actually going to call H, for the height of the dam, is the opposite side. And this side right here is next to the angle, so it's one of two sides. It's either the adjacent or the hypotenuse. The hypotenuse is the longest side, so this side has to be the adjacent. And we're only going to label those two sides because they're the only sides we're working with. So with opposite and adjacent, we're looking at TOA. So tan 22 is equal to the height of the dam, H, divided by 600. And now you can type that into a calculator. Well, sorry, you have to isolate first, so 600 times tan 22 is equal to H, and then you can put that in a calculator to find the final answer. So we'd have 600 times 22 tan equals, now I'm hoping my I think my calculator is in degrees here, 242. Does that sound right? Approximately? Yes? Okay. So it did say to the nearest meter. Let me just double check my rounding here. Yeah, so it would be 242.4, so that would be the rounding for that question. Very easy mathematically, because it's just regular trigonometry. There's only one triangle. The hardest part was were you able to draw the picture correctly, and after that I think everything should have been okay. Now we get to question 13. So this is one of those questions where it's a three-dimensional picture. I'm not going to read through the whole thing just to save us a little bit of time, but they do tell us that the surveyor's theodolite has a height of 1.7 meters. So please remind me if I forget that we're going to have to deal with that 1.7 meters at the end. But all the measurements are given in the picture, and because the picture is given, it's quite easy to see, I hope, the three-dimensional nature of this, diagram. So we have two triangles. We have triangle CBD, or BCD, whatever, and I'm actually going to draw it as a right angle triangle. So C, B, D. This is the angle 44.7, and this is the length 28.3. Okay, so if we look at this picture, there's a shared side between the two triangles, and oftentimes that is going to be what we need to find. Okay, and the logic obviously is if we find that length in the first triangle, it also is going to be a length in the second triangle. So we're going to find side CB. Side CB is opposite, let me put the right angle here, opposite the angle, and again we have the adjacent side, so opposite and adjacent. So that'll be a tangent scenario again. So we have tan 44.7 is equal to the opposite CB divided by the adjacent 28.3. I think I'm doing that okay. And the 28.3 is going to go over to the other side and multiply. Now what I did here is I just put the CB variable, on the left so that everything was ready to go. And then you just type that into your calculator. So 28.3 times 44.7 tan equals 28 is what I'm getting for that one. And then we're going to use that value in the second triangle. Now I believe the letter up here was A. I got it cut off when I took a snapshot of it. So in triangle ABC, so this was triangle, I should probably have mentioned that, CBCD. And then triangle ABC. Which looks like this. So this is now my length 28 that I just calculated, okay? And they tell us that the angle of elevation to the top of the cliff is 60.2. Now, here's something to consider for those of you planning on going on to university eventually in math and science. Because this is a two-step question, technically speaking, we shouldn't have done this step yet, okay? So I'm going to show you what I mean by that. So we are now looking for this opposite side, which is AC, right, the height of the cliff. And we are also given the adjacent side, which is the 28 that we just calculated. But this was a calculated value, right? That means that I rounded it off and I lost some precision in doing so. So here's technically the way that a university question would or probably professors would want you to answer this. You would write tan 60.2, because it is a tangent scenario, is equal to h over CB. And then you would do tan 60.2 equals h over, and you wouldn't put 28 in there. You would put the 28.3 tan 44.7 in there. And that's because you don't want to round as much as possible until the very, very last step. And I mean, technically, to be even more technical, we wouldn't have even inputted all the numbers in until we would have gotten to that version of the equation. We would have used like theta 1, theta 2. Instead of writing 28.3 here, we would have actually written CD. We would have isolated everything with respect to AC, which is the H value, and then at the very end we would have substituted everything in. Okay, that's actually the university way of solving problems. You don't put numbers in usually until the very, very last step. So it's a little bit, it might be a little bit confusing, but that's the proper way of doing it. And when I bring that over to this side, that's what I'd actually type into my calculator to find a more perfect answer before rounding it. Okay? So I'm not going to do that. I'm just going to, actually, I'm going to leave this up to you to check the answers to in the back of the book. I mean, that's the last step. Maybe somebody can just tell us what the answer is, and I'll write it down here. So what is the final height of that cliff, if you have it? $50.5. I'm trusting you. Okay, so you know, as you move on higher and higher in math, you're going to see that there's going to be conventions that are going to be introduced to you that we don't use in high school simply because it can throw some students off. But you're starting to be at the skill level to be able to understand, you know, certain things now. So that's why I wanted to just explain that a little bit more. It does make things a little bit more complicated because you're following with all these, you know, they look like bigger and bigger formulas, but it also makes things more accurate. So, okay, I'm just going to put approximation here. So moving on. Find the volume of the triangular prism to the nearest cubic centimeter. So this was one I was wondering if it would throw you off a little bit. There are multiple ways of solving this one. So the first thing I'm going to do is I'm going to just draw this triangle, this right angle triangle here. And they tell you that this is 44, and they tell you that this is 52 degrees. Right? So, oops. I just want to group this all together so it all moves at the same time. Actually, it looks like it already is. So, yeah, it already is. So this is our right angle. Right here. So one of the things was, do you remember the formula for the volume of a triangular base prism? So the volume of any prism, and a prism is defined as a shape that has the same top and bottom shape and is connected by straight lines up to the top and the bottom. Okay, so even a cylinder is technically the same shape top and bottom with straight lines connecting it top to bottom. So any prism, that's the definition of a prism, right? So the volume of a prism is always the area of the base times the height. And we're given the height. The height is 56 here, okay? But we're not given the area of the base. So how do we go about calculating the area of the base? Well, the base is a triangle, so we know that the area of a triangle is base times height over 2. The problem here is that a lot of students will say, well, I have to draw my height in, so I'm going to draw my height in like this. But as you can see, I drew my picture a little bit off, and I drew my dotted line going a little bit diagonally, and that kind of looks like that green diagonal line is going to the middle of the triangle. But if I drew it over here a little bit more carefully, it is not going to the middle of the triangle. And that is a very common mistake that I've seen students make in questions like this, is they'll just split this in half and say, well, that has to be where the height's going to, so I'm going to use half of that length, which is 22, and I'll go from there. And you can't do that here, okay? So how are you going to go about figuring out the area of that triangle? Well, one thing that a lot of students forget they can do with a right angle triangle is they can turn it this way. I thought that had been grouped. And I'm just going to delete the, I guess I can't. Okay, hold on a second. See if I can erase that angle. Because that was flipping a 52 upside down. Makes it look like a 25. Okay, so this is our 52 degree angle here. This is our right angle. This is 44. But now, with my right angle turned this way, this length becomes the base, and this length becomes the height. and now this is actually solvable. It wasn't solvable if you drop the height down from the 90-degree angle, but if you just spin that triangle around so that the 90-degree angle is on the bottom, now you can. So we've got opposite and hypotenuse for finding the height value. We've got adjacent and hypotenuse for finding the height value, or sorry, the base value. Or once we find either height or base, it doesn't matter which order you do it in, okay? If you find one of them, you could also use the Pythagorean theorem to find the other one, all right? So that's all that, you know, it's your choice as to how you want to do that. So if I do opposite and hypotenuse, that would be so, right? So sine of 52 is equal to, let's call it h over 44. And then cos 52 is equal to my base length. So I'm just going to call that b over 44. Isolating for b and h gives me those two. Okay. And now I'm going to calculate the area of my triangle. Now, I just noticed that I made a slight little mistake here. Look at how many different heights there are in what I wrote down, right? And not all of them are the same height. So this h and this h are the same, but this h is not. So I'm going to use a capital H to represent the height of my prism, just so that I don't get confused as to which height is which here. There's also the h for the hypotenuse, which we normally would call c anyway. Okay, so you got to be very careful as to how you label your variables here. So I'm going to sub in for the area of the, actually I think I'll sub in for the complete volume here because I'm ready to go. Base times height over 2 would be 44 cos 52 times 44 sine 52 all divided by 2 times capital H, which would be 56. And now I'm not carrying simplified or rounded numbers throughout my equation. I can type all that into my calculator in one step and get a much more accurate answer to that volume. Which again, I'm not going to do, but if somebody has it handy, if you want to tell us what the volume value is so people can check their answer if they didn't already. If not, we'll just move on and you can do it at a later time. And please check to see if I made any mistakes anywhere. Okay, I'm not seeing any answers pop. Oh, so 26,299. 298.8. Let's round it off to 299. I don't know if they asked us. I can't remember now. Did they ask us to round it off? Nearest cubic centimeter. Yeah, so nearest cubic centimeter would be that value right there. So we do have to round it up to 9. And that would be centimeters cubed. So the unit for volume is centimeters cubed. Okay, so I'm not sure if you've ever been introduced to this idea of not finding the final answers in alternates or previous steps needed in a multi-step equation, but putting the actual formulas from those multi-step equations into the new formula so that you're not, you know, making the error propagate throughout the entire assignment, or question in this case. So I believe those were the only 3. This is going to be a rather short lesson here, folks, because this is the last slide. And I'm going to post this in the Google Classroom as a document so that you can at least look at it. The first question comes from your textbook on page 275. It's right at the bottom of the page and it says achievement check. So let me read it to you. On a wall, a spider is 100 centimeters above a fly. The fly starts moving horizontally at a speed of 10 centimeters per second. After 1 second, the spider begins moving at twice the speed of the fly in such a way as to intercept the fly by taking a straight line path. In what direction does the spider move, and how far has the fly moved when they meet? Now, I would consider this a level 4++ difficulty level question. And I'm going to give you a few hints, okay? So here's the first hint. You're going to have to use the Pythagorean theorem to get started. Okay? Here's the second hint. Time is the variable. And here's the third hint. If velocity is equal to distance over time, that means distance is equal to velocity times time. And that's all I'm going to give you for now. In homework today, I would like you to try to come up with at least some sort of starting point for this question. And if you need help, please help each other out. Now, please don't give each other the answers. If you're going to help somebody, give them a hint as to which way to go if you know what you're doing, okay? Actually, I'm going to give you one more hint. You are going to have to use quadratics to solve the first part of this question. So if you end up with a quadratic equation, you know you're probably on the right path. All right? Now, for the second question, that is less of a challenge, all right? You may have actually already seen questions of this type. Can you find the diagonal length x in a cube so that, and this is a cube, so all side lengths are the same, okay? That is 4 by 4 on one side. But that's not enough. I also then would like you to find an expression for the diagonal length of any cube that has a side a. So instead of 4 by 4, what if it was 5 by 5? What if it was 10 by 10? Can you actually find a formula that if the side lengths were a instead of 4, that would always work no matter which cube you were given? So you may want to start with the second question before the first one, because the second question is easier. The first question is going to be quite challenging. Maybe. Depends on how you look at it. But with those hints, you should have enough to at least get started with that first one. Okay? So I'm going to stop recording here. Have a good day, everyone.